Welcome to True Projects. In this video, we are going to explain about the project which is applying machine learning algorithms for the classification of sleep disorders. So before getting into the execution, first let us understand what is the project about. So you all know right how sleep is important. So sleep it plays a crucial role in our overall health. It may be physically and also mentally. It helps us with the important functions like memory, emotional balance and also even keeping our immune system strong. When we don't get good quality of sleep, it can lead to some serious health issues like heart disease, diabetes, and also obesity sometimes. Nowadays, a lot of people they are dealing with the sleep disorders, whether it is insomnia, sleep apnea, or problems related to shift to work. It's alarming how many individuals are dissatisfied with their sleep quality. And honestly speaking, things have only gotten tougher with the COVID 19 pandemic, making it even hard for people to sleep well. So it is really clear that we need to pay more attention to keep our sleep health as it is our intertwined with our overall well being. So, when it comes to the diagnosing of the sleep disorders, we often rely on techniques called polysomnography. So, we heard the term called polysomnography, that is called as PSG for short. So, this process uses EEG and also ECG monitoring to track brain and also the heart activity during sleep. However, the downside is that manually evaluating all the data is really time consuming and it is also prone to mistakes sometimes. Plus, the data can sometimes be noisy or come with limited sources, which can be even harder to the accurate predictions. So here where some machine learning algorithms comes into the picture. So they can help to automate the process of classifying sleep stages. Traditional machine learning algorithms they can be effective, but they usually require a lot of manual feature extraction, which can be a bit of hassle. On the other hand, deep learning models tend to need a lot of data and computational resources, which can be a barrier. So, this project focuses on tackling these challenges head on. We are looking at both traditional and deep learning approaches to improve the sleep stage classification. The goal is to address issues like data biases and the complexities of feature extraction so that we can achieve more accurate diagnosis and ultimately manage sleep disorders better. So, in this project, we are proposing this project is all about automating the classification of sleep disorders. So here we are incorporating some machine learning algorithms and the deep learning algorithms. So to help with this, we are using sleep health and lifestyle dataset. So in this project, we are using sleep health and lifestyle dataset, which is publicly available. This dataset is pretty handy because it has 400 entries and each entry includes 13 features that represent different sleep patterns and daily activities. So, by analyzing this data, we aim to optimize the algorithms so we can improve how we classify sleep disorders. This approach will make the whole process more efficient and accurate, which is really important for helping people manage their sleep issues better. So, in this project, we are incorporating different machine learning algorithms to classify sleep disorders. So, here we are incorporating K nearest neighbors, support vector machine, decision tree, random forest, and artificial neural network. Each of these models has its strengths, and we want to see which one performs the best for the specific task. To make sure that we get best out of each model, in this project we are using Grid Search CV, that is Grid Search cross validation to hyperparameter, I mean for hyperparameter tuning. That means to perform well. So this technique helps us fine tune the hyperparameters of each model, which are basically the settings that can significantly affect the performance. Once we have everything set up, we will train and test these models using the dataset. By doing this, we can compare their performances and figure out which algorithm is the most effective ones for accurately classifying sleep disorders. So, to further improve the performance in this project, we are incorporating an advanced ensemble model voting classifier as the extension of the project. So, what this does is it will combine the predictions from different individual models, which really help us to improve the overall performance of the system. By doing this, we can create a more robust and accurate final prediction. This method is really great for addressing some of the issues we might face with the standalone algorithms like overfitting and bias, which can lead to less reliable results. On top of that, we have built front end using Flask framework. So this makes it super easy for users to interact with the system. They can input their relevant data and see the predictions in a user friendly way. And we really wanted to ensure the user data is kept private and secure. So we integrated user authentication mechanism. So here we have incorporated user authentication mechanism to keep the user data securely. So this not only allows users to access the application safely, but also enables us to gather practical testing. Overall, these extensions enhance the functionality and usability of the project, making it more effective for users who are looking for solutions related to sleep disorders. Moving on to the implementation of the project, we have followed the steps in the flow of work to implement the project. So let's understand them. First, we have imported the necessary packages which are required for the execution. And then we loaded the sleep disorder data, and then we did exploratory data analysis to understand the structure and the contents of the data set. After understanding structure, then we did some pre-processing where we have removed the duplicate data and we also removed the null values. And then we have visualized the data using some graphs. Then we converted categorical data into numerical data using label encoding technique. Then we appended all the features to X variable and the target column to Y variable. And we split the data into train and test sets. So train set is used to train the models, validation set is used to test the models, that is how well they have performed on the unseen data. And then we build the models. Then we fit the data, that is train set, with the building with the models built. And then we compare them using accuracy, precision, recall, FN score, AUC specificity, and sensitivity. So we will be evaluating all the algorithms using all these metrics and we will be comparing which model has performed well. Then we compare them through graphs also, and we have developed front end using Flask framework, which is integrated with the SQLite 3 database. And in the front end, users they will be able to give the feature values. That feature values will be pre-processed at the backend and it will be fit with the train model. And finally, we will be getting the prediction related to the sleep disorder of a patient. Moving on to the algorithms used. So these are the algorithms used in the project to classify the sleep disorders. So we have used support vector machine, KNN, which is nothing but K nearest neighbor, decision tree, random forest. ANN is nothing but artificial neural network. And the last one is voting classifier, which is the extension. And this model has performed well. So we have used it for predicting the sleep disorder in the front end. Moving on, to implement this project, we need basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now, to execute, we need to open the code folder which contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. In this archive folder, we have the dataset. So this is the sleep, health, and lifestyle dataset that is used in the project. So these are the attributes which are used to predict the sleep disorder. So these are the independent variables which impact the sleep disorder. And in the last column, we have the target variable, that is the target column, sleep disorder, where none represents person has no disease related to sleep. And the sleep apnea is one type of sleep disorder, and insomnia is also one type of sleep disorder. Now we will be using this data to train all the models for predicting the sleep disorder. Let's close this, get back. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. And these are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And coming to this app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contain the algorithm information, and this will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. And here in the sample file, we have the test cases. That test cases we will be using in the front end to predict the sleep disorder. So now copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Anaconda prompt is opened. Now use the command cd followed by the space, paste the copied path and click on enter. If you observe here, current directory is changed to the code folder's path. Now we have to compile the app.py file by using the command python space app.py and now click on enter. So this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. Now I prefer Google Chrome, so I'll paste it in Google Chrome. Now paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to register first, so click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. So click on sign in, give your username and the password, click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? So we need to fill in all these parameters to predict the sleep disorder. Let's understand these parameters first. So the first one we have is gender. This refers to the biological sex of the individual, which can influence sleep patterns and health conditions. Coming to age, age is a crucial factor as it affects sleep needs and patterns, with different age groups experiencing distinct sleep characteristics. Coming to occupation, the individual's job can impact sleep quality and duration, especially if it involves shift works or high stress. Coming to sleep duration, this measures the total time spent asleep, which is essential for assessing whether an individual is getting adequate rest or not. Coming to quality of sleep, this refers to how restful and restorative the sleep is. That is, restorative the sleep is, influencing overall well being and daily functioning. Coming to physical activity level, this indicates the amount of intensity of physical exercise, which can significantly affect sleep quality and duration. Coming to stress level, it is the level of stress experienced by an individual can impact sleep patterns and overall health. Coming to BMI category, this categorizes individuals based on their body mass index, which can be linked to various health conditions affecting sleep. Blood pressure. Blood pressure measurements can indicate cardiovascular health, which is often related to sleep quality. Coming to heart rate, this refers to the number of heartbeats per minute, which can reflect overall fitness and stress levels affect the sleep. The last one we have is daily steps. This measures the number of steps taken each day, serving as a proxy for overall physical activity and its influence on sleep health. So we understood all these parameters. Let's enter them. For that, we have to open the sample file. So this is the file in which we have test cases that we have to open now. So let's open it. So these are the test cases which we are supposed to enter. Let us fill in all the parameters. So let's use the first test case. So this is the first test case. So age of the person is gender of the person is 0, which is nothing but the person is male. And the next one is age, which is 53. Occupation is 2. Sleep duration is 8.5 hours. Quality of sleep is 9. Physical activity level is 30. Stress level is 3. BMI category is 0. Blood pressure is 9. Heart rate is 65. Next we have is daily steps. So the daily steps is 5,000. Now let's click on predict. This input will be pre-processed at the back end and then we will be getting the prediction. So here we got the prediction that patient is not suffering from any sleep disorder, is completely healthy. Let's try with the one more test case. Click on prediction again. So let's try with the seventh test case where the gender of the person is 1, age is 44, occupation is 7, sleeping hours is 6.4 hours, quality of sleep is 6, physical activity is 45, stress level is 7, body mass index is 3, blood pressure is 15, heart rate is 72, daily steps are 6,000. So now click on predict. So based on the given input here, we got the prediction as patient is suffering with the insomnia, which is a common sleep disorder that can make it hard to fall asleep or stay asleep. Which means the person having insomnia will be not able to sleep properly. He will always be asleep. Let's try with the other test case. Click on prediction. So let's try with this 34th test case where gender is 0, age of the person is 59, occupation is 5, sleeping hours is 8.2, quality of sleep is 9, physical activity is 75, stress level is 3, body mass index category is 3, blood pressure is 23, heart rate is 68. The next one we have is daily steps. So daily steps would be 7,000. Now click on predict. So here we got the prediction that patient is suffering with the sleep apnea and it is potentially a serious sleep disorder in which breathing repeatedly stops and starts. So when a person is having sleep apnea, he will have a disorder where he will be not able to breathe repeatedly and his breath repeatedly stops and starts. Let's try using one more test case. So click on prediction. Let's try with this test case. So gender is 0, age of the person is 37, occupation is 0, sleep duration is 7.2 hours, quality of sleep is 8 hours, 8 it is 8, and physical activity is 60, stress level is 4, BMI category is 0, blood pressure is 0, heart rate is 68, and the last we have daily steps is 7,000. Click on predict. And here we got the prediction that patient is not suffering from any sleep disorder. Let's try with the one more test case. Let us try with this test case. Click on prediction. Gender is 1, age is 28, occupation is 9, sleeping hours is 5.9, quality of sleep is 4, physical activity is 30, stress level is 8, BMI index is 2, 22 is the blood pressure, heart rate is 85, and the last one we have is daily steps. So the daily steps would be 3,000. Now click on predict. So here we got the prediction that patient is suffering with insomnia. It is a common sleep disorder that can make it hard to fall asleep or stay asleep. So this is how we need to give inputs to the parameters based on the given parameters. Then we will be getting the prediction. Now let's check with the graph. So click on graph. So this is the sample outcome graph. This shows the distribution of the target class, where on x-axis we have the different classes that we are predicting, and on y-axis we have the count of each class. Here, this is the none, that is none class, which means person has no sleep disorder, and this is the sleep apnea disorder. This is the count of sleep apnea disorder, and this is the insomnia's count. Moving on, here we have accuracy graph. So accuracy is a metric used to evaluate all the algorithms built in the project. Here on x-axis we have accuracy score and on y-axis we have algorithm names. If you observe, voting classifier, the extension model is having the highest accuracy. And this is the precision score comparison graph. And here we have FN score, recall score, and that's all. So now click on log out. In this way, by using the machine learning models and tuning them, and by using the extension model, we will be able to predict the sleep disorder accurately, and this will help the patients as well as doctors to diagnose it early and treat it in the early stages itself.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.